Hello all, today we're going to perform an experiment to precipitate calcium as calcium oxalate monohydrate. To begin, weigh between 1.2 and 1.5 grams of the solid unknown using a clean, dry 250 milliliters beaker. The sample should first be dry in a 105 degrees Celsius oven for 1 hour to remove moisture. Add 30 milliliters of deionized water followed by 12 milliliters of 3 molar hydrochloric acid. Stir until the unknown dissolves completely. Allow the solution to cool and quantitatively transfer it to a 100 milliliters volumetric flask, rinsing the beaker at least 3 times to ensure complete transfer. Fill to the calibration mark with deionized water. Rinse a 25 milliliters pipette with small portions of the prepared solution and transfer exactly 25.00 milliliters of the solution into each of 3 beakers. Dilute each beaker with approximately 75 milliliters of 0.9 molar hydrochloric acid. Then add 5 drops of methyl red indicator. To precipitate calcium as calcium oxalate monohydrate, add 25 milliliters of ammonium oxalate solution to each beaker. Then add approximately 15 grams of solid urea to each samples and cover with a wash glass. For the next step, slowly and gently boil all 3 samples for about 30 minutes or until the indicator turns yellow. Then carefully remove the beaker using a washcloth. Filter each hot solution through a sintered glass funnel using suction. Add 3 ml of ice-cold water to each beaker and use a rubber policeman to transfer any remaining precipitate into the funnel. Rinse the beaker with additional small portions of ice-cold water until all solid has been transferred. Finally, rinse each beaker with 2 10 ml portions of ice-cold water, pouring the washings over the precipitate. Complete the analysis. Dry the precipitate in 105 degrees Celsius oven for 1 day. Cool the funnel in the desiccator and record the mass for each sample. This is the raw data gained from the experiment. This data then is used to make the calculation. For the manual calculation, first we calculated the percentage of calcium inside the calcium oxalate monohydrate. Then, by using the data of the 3 trials, we can determine the standard deviation and also the relative standard deviation. To ensure the calculation is precise, Microsoft Excel is used to calculate using software. Let's go to the discussion part. The analysis yielded mean calcium weight percent of 7.94%, the standard deviation of 1.39, and the high relative standard deviation (RSD) of 17.5%. This RSD significantly exceeds the typical analytical limit of 5%, indicating low precision and poor reproducibility. A wide variance against inconsistent errors occurred. The lowest value likely resulted from mechanical loss of precipitate during filtration or incomplete quantitative transfer. The highest value implies incomplete drying, where residual moisture artificially inflated the mass. To avoid getting high value of RSD, we need to follow some precautions. Laboratory fans must be switched off when handling fine powders to prevent mass loss. Glassware should never be touched with bare hands, as skin oil affect weight. Tissues or tongues are required. Crucible must cool to room temperature in a desiccator before weighing to prevent convection current from destabilizing reading. Finally, thorough quantitative transfer using a rubber policeman is critical for accurate result. For a final conclusion, the experiment successfully determined a mean calcium weight percent of 7.94%. However, the high relative standard deviation of 17.5% indicates low precision due to experimental errors like sample loss or incomplete drying. Future iteration requires strict adherence to handling and transfer precautions to improve reproducibility and accuracy.